Hello students, today we will discuss some more number of problems related to Maxwell's loop analysis. In previous class already I told you how to solve the Maxwell's loop analysis, and different type of problem has been asked in your some competitive examination like GATE, IS and also some public sector exam. You will find different type of problems, how your approach to solve this type of problem. If you are going to solve related to Maxwell's loop analysis, if there is a current source, immediately you have to convert it into the voltage source. These problems, the question is find the voltage across this 3 ohm resistor or find the voltage across this branch AB. Okay. In this problem, there are two current source. Here there is a current source. This is also a current source and this is also current source. If there is a current source, immediately we can convert it into the voltage source. And this is your 2 ampere here, and how will you convert the current source into voltage source, already I told you in a previous lecture. So this is your 2 ampere and this is your 5 ohm. So the voltage source will be how much? 2 into 5, that is your 10 volt, and this is your, if you rerun the circuit, this is your minus terminal, this is your plus terminal, this is your 10 volt and series with this 5 ohm resistor, this is your 5 ohm resistor. Again this branch is let A, this point is A, and this 3 ohm into 1 ampere, 3 into 1, that is your 3 volt. Direction of voltage source is your minus and this is your plus here, because the current direction here minus to plus is plus, that is your what, the direction is like this. Here this direction is same, so that is your 3 into 1, that is your 3 volt, this is your 3 volt, and the resistance is 3 ohm and this is your 3 ohm. And then this point is what? This point is B, and here there is your 2 volt plus minus, that is your 2 volt, and then 2 ohm, and this is your 5 ohm, and this is your 3 volt, your 3 volt. Okay. First of all, what you will do, this current source can be converted into the voltage source. 5 into 2, 10 volt, and series with 5 ohm resistor here, and this is your current source. 3 into 1, 3 volt, and the direction is minus terminal, this is your plus terminal. Remember, the direction of voltage source should be same as the current source. 3 into 1, 3 volt, and 3 ohm resistor is series, and as usual this is 2 volt, 2 ohm, 2 volt, 2 ohm, this is 5 ohm, and this is 3 volt. So we will find two loop, and this is your loop 1 and this is your loop 2, and let this is your I1 and this is your what? I2. When you are going to solve Maxwell's loop analysis, using Maxwell's loop analysis, first of all find the loop current I1 and I2. There are two loops, so we will find the two loop current I1 and I2. So as usual procedure, so resistance matrix into current matrix is your voltage matrix, R into I equal to V. So resistance matrix, since it is your two loop, that is your 2 into 2 matrix, R11, R12, R21, R22. This is your resistance matrix, and current matrix let I1, I2, and voltage matrix, that is your V1 and V2. This is your R into I equal to V. Okay. First of all, how to find out R11? R11 is nothing but sum of the resistance formed by the loop 1. In loop 1, how many number of resistance? 1, 2 and 3, 3 resistance. So if you add 5 plus 3, 8, 8 plus 2, 10. R11 is your 10 ohm. Similarly, R12, the resistance common between 1 and 2. Common between 1 and 2, that is your what? 2, that is your minus 2. Similarly, 2, 1, 1 to 2, 1 is same, that is your minus 2. 2, 2, sum of the resistance formed by the loop 2. In loop 2, what? How many number of resistance here? 2 plus 5, that is your 7. This is your resistance matrix. And current matrix, let this is your I1 and this is your I2. I1, I2 equal to the voltage, the net voltage. Tell me the net voltage. Already I told you, if the direction of current is same as the voltage, that will be plus. Here the direction of minus to plus, the direction of voltage source is like this. Here also the direction of voltage source is like this. Here also the direction of voltage source like this. First consider the loop 1. How many number of voltage source? 1, 2 and 3. Already you know the 3 voltage source in the loop 1. So, and thing is, the direction of voltage source, the magnitude of this voltage source either plus or minus depending upon this current, loop current. If this direction of the loop current is same as this direction of voltage source, it will be plus. First come to this 10 volt, the plus or minus. The direction of current I1 is same as this voltage source, it will be plus, that is a plus 10 volt. Then this your direction of this current is same as this voltage source, that will be plus, that is your what? 3 volt. The 10 plus 3, 10 plus 3. Then here the direction of current is same, is opposite to the direction of voltage source is opposite, minus plus plus. The direction of the current I1 is opposite to this voltage direction, that will be minus. So 10 plus 3 minus what? That is your 2. That is your net voltage in the loop 1. Then come to the net voltage in the loop 2. In loop 2, how many number of voltage source? 2 voltage source. Here the loop current I2 is opposite to this direction of this voltage, that will be minus. This is your minus 3. This is your minus 3. And this loop current I2 is same as your voltage direction, 2 volt, that will be plus 2. Minus 3 plus 2. This is nothing but what? That is your net voltage loop 1 and loop 2, V1 and V2. That is your, if you simplify this 10 minus 2 minus 2, 7, this is your resistance matrix, this is your I1 and I2, and voltage is nothing but 10 plus 3, 13 minus 2, that is your 11, and this is your minus 1. So from this we will calculate the value of I1 and I2. How to calculate I1? So I1 equal to, I1 is nothing but what? Simply you close this one using Cramer's rule. First column you will get 11 minus 1, 11 minus 1, then minus 2, 7. This divided by this resistance matrix R, the value of R. Tell me what is the value of R? R value is how much? If you multiply this into this, 10 into 7, 70, minus minus plus minus minus, 2 into 2, 4, 70 minus 4, that is your 66. The value of R is your 66, and this is your 66. So which is equal to, that is your 11 into 7, 77, minus minus plus minus minus, 2 into 1, 2, divided by 66. The value is your 77 minus 2, 75, 75 divided by 66, what? Ampere. The value of I1, the value of I1 equal to your, I1 equal to 75 by 66 ampere. Then I2, how to calculate I2? How to calculate I2? So I2 value is how much? So I2 is nothing but, I2 equal to, how to calculate I2? I2 equal to your, I2 by using Cramer's rule. Using Cramer's rule, simply you close the second column, that is your 10 minus 2, this is your 10 minus 2, then 11 minus 1, this divided by this resistance R. So this value is how much? The value is your how much? 10 into minus 1, minus 10, minus minus plus, 11 into 2, 22, divided by R, R value is your 66. And this will be how much? Minus 10 plus 22, that is your 12, 12 by 66, 12 by 66 ampere. The value of I2 here, that is your 12 by 66, which equal to how much? Using calculator, 75 by 66, 75 by 66, so 75 divided by 66, the value is your 1.136 ampere, that is your I1. And the I2 value is how much? I2 is your 12 divided by 66, the value is your what? 0.18 ampere. This is your I2. Then what will do? After getting I1 and I2, you have to find out this branch voltage across AB. The voltage across AB, how you will calculate the voltage across AB? Remember, the voltage across AB means what? That is your here, that is your, this is your 3 volt, this is your 3 volt, this is your 3 ohm, this is your 3 ohm, and this point is B and this point is A. That means we will calculate VAB, voltage across AB. How to calculate voltage across AB? How to calculate the voltage across AB? So the current flow through this 3 ohm is how much? This is your I1. Indirectly the current flowing through this one is nothing but what? I1. So I1 already we have calculated the value of I1 equal to 1.136 ampere. So VAB is how much? If you apply KVL, so VAB is what? VAB minus plus 3 volt plus this is your plus and this is your minus 3 I1 equal to 0, or VAB equal to 3 I1 minus 3. VAB equal to 3 I1 minus 3. Already I1 we calculated 1.136 ampere. So VAB, voltage across AB, is how much? That is your voltage across AB equal to 3 I1, 3 into I1. I1 value is your 3 into 1.136 ampere minus, that is your 3. The value is how much? So 3 into 1.36. So using calculator, that is your 3 into 1.136, that is your 3.408. So 3.408 volt minus 3, the value becomes what? 0.408 volt. Okay, so that is what? So voltage across AB, VAB equal to how much? 0.408 volt. Your answer is your, the voltage across AB, voltage across 3 ohm resistor is nothing but what? 0.408 volt. So in this way you can calculate, if there is a current source, immediately you can convert it into voltage source, then apply using Maxwell's loop analysis, resistance matrix into current matrix equal to voltage matrix. You found how many number of loops. If the number is, if there are 2 loops, there are 2 into resistance matrix. If there are 3 loops, there is your 3 into 3 resistance matrix. Using Cramer's rule, 3 unknown values I1, I2, and if I1, I2 can be calculated, then again you go through the first initially what question mentioned. The question mentioned is find out the current through this 3 ohm, the branch AB. You can apply the simply, this is your 3 and this is your 1, this is your minus 3 volt and this is your 3 ohm. So that part we have to calculate it, this one voltage across AB. Again if you apply the KVL, VAB minus plus 3 minus 3 I1 equal to 0, VAB equal to 3 I1 minus 3 volt. The result will be 0.408 volt. Okay. Next class again we will do more and more number of problems, different types of problems, so that your fundamental will be clear, and if you appear in your some competitive examinations, that it will be very easy for you. Okay, thank you.